Hey folks, welcome to another video. This one will be NixOS number 88, and this is the third in a series of videos that I'm doing going over Eelco Dolstra's PhD thesis that forms the basis for Nix. This particular one will go over section 2.2 called Nix expressions. No one's watching this. I went and looked at the view stats for the last video. So I tell you what, it's just going to be me and you. They won't know what they're missing. They won't know. They're not watching. We're going to have like a lot of fun. And they just won't even know. Well, it's going to be awesome. All right. This is going to cover pages 25 to 34. This is a chapter that talks about Nix expressions. It doesn't really describe the ins and outs of the Nix language, but it just gives an example of a Nix expression that's used to build a derivation, and sort of takes us through why you might write such a thing. Nix components are built from Nix expressions. The language of Nix expressions is a simple, purely functional language used to describe components and the compositions thereof. And he's talking about building a hello world component, GNU hello. And so in order to do so, he's going to do that in 3 steps. We're going to write a Nix expression for the component. We're going to write a builder, figure 2.7. This is typically a shell script that goes along with the Nix expression that actually builds the component from the inputs. And then we're going to create a composition. And the composition that's the thing that allows Nix to put it in the Nix store. To compose the component with its dependencies, we must write another Nix expression that calls the function with appropriate arguments. Figure 2.5 shows a directory structure of parts of the Nix packages package collection, including some Nix expression builders and miscellaneous inputs contained therein. He's talking about something called Nix packages, which still exists today. This was written in 2006. Currently, it is a GitHub repository. I'm sure back then it was not. It is a collection of files, and it is rooted at a directory called Nix packages. There's a subdirectory called packages underneath of that. And then inside of packages, there's application development system. These are sort of like categories of things to build. Inside applications, we have miscellaneous applications, networking applications, development libraries, development compilers, development interpreters, et cetera, et cetera, et cetera. But all these things, this tree is full of .nix files and maybe shell files and patch files, whatever's needed to do the job. Figure 2.6, part 2 here states the expression as a function. So this little bit of hair here, the curly bracket, name, comma name, and curly bracket, colon, this is a function. This expression is a function. And the function expects to be called with 3 arguments: standard env, fetch URL, and Perl. They're needed to build hello. They are themselves things that can be built. We don't know how to build them here, so they're function arguments. Standard env is a component that's used by almost all Nix packages components. It provides a standard environment consisting of the things one expects in a basic Unix environment: C compiler, Unix shell, Unix tools like copy and grep, and blah, 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 blah. Perl is the Perl interpreter. He says the Nix functions generally have the form open curly bracket x, comma y, ellipsis, comma z, and curly bracket, colon, e, where x, y are names, and e is the body, the result of the function. So whatever's evaluated last in a function body is its result. The result of this function, in this case, is a derivation. This is Nix speak for component build action, which derives the component from its inputs. And then he sort of slips in this description of an attribute set. He says we perform a derivation by calling standard env make derivation. Make derivation is a function provided by standard env that builds a component from a set of attributes. An attribute set is just a list of key value pairs where each value is an arbitrary Nix expression. So this here is an attribute set. Name equal blah, builder equal blah, source equal blah. And then this little bit of syntaxy hair down here, there at Perl. A few of the attributes derivations are special. Attribute name specifies the symbolic name and version of the component. So, symbolic name and version. It is dependent of the cryptographic cache. Yep. Attribute builder specifies the script that actually builds the component, usually a shell script. It can sometimes be omitted, and then a default builder will be used. Number 6, builder has to know what the sources of the component are. Attribute source is bound the result of a call to the fetch URL function. This fetch URL function is something that will accept these 2 arguments, this URL and MD5. It will go download this file from that URL. It will make sure that its MD5 hash matches that what's pasted in here. Since the derivation requires Perl, we have to pass the value Perl function argument, the Perl function argument to the builder. All attributes of set are actually pass as environment variables to the builder. So declaring an attribute Perl equal Perl will do the trick. It binds an attribute Perl function argument, which also happens to be called Perl. However, this looks a bit silly, so there's a shorter syntax. The inherit keyword causes the specified attributes. Okay, so I think this is where people start to fall off of Nix. So that tells you where you have fun. So what he's saying here is that by virtue of saying Perl equals Perl here, but he doesn't have Perl equal Perl, he says inherit Perl, the environment of the builder will have an environment variable with the key Perl, P in lowercase. Its value, I don't think he's talked about its value yet. Its value, I happen to know, will be the path to the Perl component in the store. So the next path to the Perl component in the store. That means in the environment, we will have Perl equals Nix store Perl, blah, 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 Perl 571 or whatever. That'll be in the builder's environment. But then he goes on to say, saying Perl equal Perl is silly. So there's a short syntax, the inherit keyword. So in order to inject the Perl environment variable into the builder script, we say inherit Perl, and that is the same as saying Perl. Told you we're going to have fun. The builder itself is this shell script. The attributes in the attribute set of the derivation are passed as environment variables. Attribute values that evaluate the derivation, such as Perl, are built recursively. The paths of the resulting components are passed through the corresponding environment variable. So that's what I was just talking about here, where I said that. What happened? Where's my, that's that. Special environment variable out holds the intended output path. This is where the builder should store its results. When Nix runs the builder, it initially completely clears all environment variables, except for the attributes that declare in the derivation. For example, the path variable is empty. This is done to prevent undeclared inputs. We talked about that in that last video. It's putting like C, GCC on the path and the things that are in standard in. Since hello needs Perl, we have to make sure that Perl is in the path. We choose to put the Perl bin directory on the path by saying path equals Perl bin : path. To unpack the sources, we just use tar, which is part of, I guess tar was put on the path via the sourcing of standard in setup. Autoconf package. All right, so we're going to talk about the composition of the hello component. Since the Nix expression for hello in figure 2.6 is a function, we cannot use it directly. We need to compose it first. That is, when you have to call the function with the expected argument. So what he's saying is this is a function. This denotes that the expression is a function. And we have to arrange for this function to be called with standard in, with the correct standard in, the correct fetch URL, and the correct Perl. Talking about Nix packages, where this is done for a large collection of packages. And this is, I think, in spirit, some of this is still around. I think this all packages thing recently got retired for sort of a file system discovery based thing. But in spirit, I think most of this stuff still exists in Nix packages. He's saying that there is a file called allpackagesgeneric.nix where all Nix expressions for components are imported and called with appropriate arguments. So he's saying 13 file defines a set of attributes. Here's our hello. This is the all packages generic Nix. Say hello equals please import this file, which is that, not that thing, that thing. That's hello. That's our hello expression. We're going to call it with fetch URL, standard env, and Perl as arguments. And the fetch URL, standard env, and Perl that we're calling the specific realizations of those things are here. Perl equals that, fetch URL equals that, standard env equals that. And furthermore, we define a mutually recursive set of attributes using the keyword rec. That is, attributes can refer to each other. When we do this, the ordering of this top level thing that is trying to compose hello or anything is unimportant. Just because we're referring to fetch URL standard and Perl in here, it doesn't mean that fetch URL standard and Perl need to be defined before hello is defined. That's not how this works. With this recursive thing, what it does is it will do the right topological sort in order to resolve the names of these things in order, in the order required by whatever happens to be evaluated. You know what I'm saying? I think you know what I'm saying. But this is unlike many other languages, many other imperative languages, where if you had tried to refer to fetch URL here, it's not a scoping thing. It's not, fetch URL is not outside of this attribute set. It is a peer here, and at recursive attribute sets can use names that are not only in the enclosing scope, but also are in the attribute set that you are defining, and it will figure the ordering out for you. Got it? Okay. The attributes can refer to each other. So he does say here, while attributes can refer to the values defined in the same scope, derivations cannot be mutual dependencies. So you can't have a circular dependency, or you can't say that hello depends on Perl and Perl depends on hello. That'll give an error. But if there are no cycles in the dependency, it will order the thing on your behalf, which is super nice. And then he talks a little bit about what it means to import a directory. Importing a directory just means importing the default.nix that's inside of that directory. So /applications misc hello. Import applications misc hello is the same as saying import applications misc hello default.nix. 15, this is where the actual composition takes place. So we're passing in this fetch URL, this standard env, and this Perl to hello in order to compose it or call the function or whatever we want to call it. Nix functions arguments are not positional. Nix functions just expect an attribute set containing attributes corresponding to the clariformal name. So this is sort of like keyword arguments in Python. Keyword only arguments in Python. The result of this function call is an actual derivation that can be built by Nix. Likewise, concrete instances of Perl fetch URL in standard environment is constructed by calling their functions the appropriate argument. So we're also building Perl here, and we're building fetch URL. And we don't see the definitions of these derivations, but presumably they're a lot like this one. So then he goes on to describe how this differs from existing build systems. He says, surprisingly, describing not just components but also compositions is not a common feature of the component description formalisms of deployment systems. For instance, RPM spec files describe how to build components, but not how to build the dependencies of those components, even though the dependencies can have a profound effect on the build result. The actual composition is left implicit. So this is in RPM or, apt or not apt, but dpackage or whatever it is. Things have to line up by specifications, version numbers, there might be a little loosey-goosey, I accept version 1.1 through version 1.3 or exactly this version, or it doesn't really matter which version I get or whatever. There's no validation. Developer, the packager takes a guess. Actual composition is left implicit. That is a woeful underspecification. Only a full set of RPM spec files closed under the dependency relation fully describes component build. His claim is that in order for RPM to do the same thing as this, it would need to have something like Nix packages where set of RPM spec files circumscribed. So we have another example of building subversion. I'm really glad that he chose things that weren't like Haskell and more familiar things to people that are system administrators and programmers of not Haskell. So he's talking about building subversion. We can support variability in builds by allowing people to pass in, in this case, Boolean saying, yes, I want subversion to be built with BDB support, HTTP server support, and SSL support, or not. I'm very curious, like seeing that you do this, like seeing that you twist yourself into this formatting where you lead off a line with a comma. Why wouldn't you just make the language support trailing commas? I don't know. Anyway, Okay, so he shows the actual calling of this function or the composition of this component. He says this is like the minimal feature version, and then if you want the full feature version, you can call it with all these arguments. Yep. So these are just assertions. Before it will go ahead and build the thing. It'll just these are belt and suspenders things to say. Given that someone who is not me, I'm writing this Nix file. So given that someone who's not me is calling this function, they may supply the wrong arguments, and it may wind up in a build that can't be done. So might as well give them a little bit of help. And then he just sort of in passing says, unused dependencies will not be evaluated, let alone be built due to the fact that Nix expressions are lazy languages. So this is tugging on a sweater thread that I'm sure we'll talk much about later. The builder for subversion components, just to give an idea what is involved in getting a non-trivial piece of software to work. So this is the builder for subversion here. And we have a set of build inputs. And remember that these things get turned into environment variables when they're attributes of here. And we source standard M setup thing in order to put GCC and whatnot, tar and stuff on the path. Get configure flags that we need. And then we test against the flags and we change the configure line based on those things. Yeah. So he's just talking about sort of fitting into the autoconf world here. Yep. Okay. All right. Well, I think that's all we have time for today. I will do another one soon. I suppose the next one will be this 2.3 package management chapter. Good times. Well, if you watch this far, wow. Touch grass, man. Touch grass.